All right. Remember when we were doing quotient rule and then suddenly products started turning up inside it? Well, now that's happening again, but in a different way. What we have here, this is another nesting of differentiation rules, is we have a product, because this is 3x squared times the stuff in brackets. But the stuff in brackets is going to trigger the chain rule because we have a cube and inside it we have another function. So this is going to be a combination of product rule and chain rule, and let's see how that works. When we do our derivative, df dx, firstly, because this is a product, the product rule will apply. And the product rule, you will remember, goes first d second plus second d first, or if you're writing fg prime plus f prime g, that's perfectly good also. So let's see what we can fill in here. Our first is 3x squared. Derivative of the second, time to switch colors. Now we have to do the derivative of this thing, which is a function within a function. We must use the chain rule here. It starts out as 3 times bracket to the second power, and 2 minus x squared goes in there. That is our outermost layer. Now that we've done that layer, we forget about the third power and we do the derivative of what was inside it, the derivative of 2 minus x squared. So, derivative of 2, 0. Derivative of minus x squared should be minus 2x. Those two things multiplied together are the derivative of the second piece. Now, before that started, we were in the middle of doing the product rule, so now we revert to doing that. We have first d second plus second part here is 2 minus x squared to the third power, and the derivative of the first, meaning the derivative of 3x squared, is simply 6x. Good? First d second, chain rule triggers here, plus second d first. So you just have to put what you're doing on hold, do this smaller task, and then get back to the bigger task. It's important to label things and stay organized. I recommend you actually write something like this above each section when you're starting out, just to make sure that you get all your pieces in the right place. And after you've practiced for a week, you probably won't need to do that anymore. Let's see if we can spiff this up at all. We have 3x squared. What am I doing here? Let's see. We have 3x squared. We have this 3, and we have this minus 2x. We can mash all that together. 3 times 3 is 9, times minus 2 is minus 18. X to the x squared times another x makes x cubed. So that takes care of all our monomials. They're all condensed now. And then we have our 2 minus x squared to the second power from here. Good. Second section is much simpler. We have 6x, and then we have 2 minus x squared to the third power. Okay, can we do anything to improve on that? There is a factored form that we could get to. I'll do this quick because this isn't the main focus here, but if you want to stop here, that's not a bad place to stop. If you wanted to make improvements to this, I would factor out a 6 because of the common factor here. I would factor out a single x. I would take out a leading negative because leading negatives bug me. And we could take out 2 minus x squared to the second power. And if you do all that, take out minus 6x and 2 minus x squared squared. What remains after that would be 3x squared minus 2 minus x squared. That's because here we had 6x divided by negative 6x, so that leaves us with minus 1. And 2 minus x squared to the third power divided by second power leaves first power. If we clean that up, 6x, 2 minus x squared squared. What do we have here? 3x squared plus another x squared is 4x squared minus 2. You could factor a 2 out of that, I guess, if you're really gung-ho. 2 minus x squared squared, leaving 2x squared minus 1. So, okay place to stop, also a good place to stop. In a few weeks, when we're solving these and setting them equal to 0, this will be a very good place to go. For now, the main focus is we want you to be handling the fact that this is a product with a chain inside it. And so if you're doing those two rules correctly and you stop here, that's fine with us.